In this video, I'd like to explore the physics behind actors. So far we've been adding attributes and behaviors to our actors and driving them around the screen, but we also can apply some really advanced real-world physics to our actors, things like gravity and bounciness. So let's start exploring that. And you'll also notice in a lot of these tutorials, I'm not working with a whole lot of artwork. And that's not because I'm lazy and don't want you to have access to a lot of beautiful artwork while you're learning GameSalad. It's because rapid prototyping with simple characters or simple actors that are just these squares will really help you understand the mechanics behind GameSalad before you start worrying about getting into the graphics. Because if you have beautiful artwork, but you don't have a game that works very well, then it's not going to be a very good game. So it's good to kind of experiment often with just simple actors and get things perfected that way before you actually start plugging in artwork. So let's do that now. Let's understand a little bit more about physics by creating a few simple actors. So the first actor I'm going to create is actor 1, and then the second actor I'm going to create, I'm just going to name this actor ground. And we'll double click on the ground actor and let's change its color a little bit so we can tell the difference between actor 1 and our ground actor. And I'm just going to drag the ground actor here inside our stage. And we can grab these handles here to stretch that out. And I can just drag the ground actor in a few more times and grab this handle to rotate. I can also hold the Alt or Option key and click on that actor to kind of duplicate it and move it along. And you just want to kind of create a very, very quick and simple terrain here that we can play with. And this is what I'm talking about as far as simple and rapid prototyping of things. Instead of spending hours and hours and hours creating graphics to then plug them in and see how they work in your game, you can understand a lot about the mechanics of GameSalad by just quickly creating things like this. So we'll drag actor 1 inside our stage as well. So if we hit the preview button, nothing happens. We just have this white actor floating in outer space. And we want to start applying some physics to this, some real-world gravity. So the way that we do that is in our Scene tab. We can click on that. You notice that we have a gravity pull down. And Y, being the up and down direction, is set to 0. So if we were to set gravity here to something like 10, and then preview, you're going to see everything slowly starts to drop down. If I were to set the scene gravity to 100 and click preview, you can see everything starts to drop down a lot faster, so our gravity is a lot more intense. The same is true if I type in -100 and hit preview. You can see everything starts to float up because I've now kind of made a negative value for the gravity. We can also have our gravity for Y set to 50, and then if we wanted to, we could set our gravity for X to something like 30. And that's really what's so amazing about game design. Your limits are kind of only where your imagination can take you. So if we hit preview, now you can see we have gravity going down, but also to the left as well. So for this video, let's not worry about our X having any sort of value. Let's just set our Y gravity as something like 100. That way we have everything kind of falling down. Perfect. So we don't want the ground falling down. That doesn't make a whole lot of sense. So if we double click on the ground, you can see in the ground attributes we have this physics pull down, and this is what we're going to be editing for both of our actors. So you notice the very first thing that we have here that we're going to edit is something called movable, and it's checked to on, which essentially means the ground is movable. So we have gravity in our scene, and because our ground is movable, it's being moved. So let's just uncheck that and see what happens. When we preview that, now only actor 1 is moving, but our ground isn't. But actor 1 just flies through the ground like a ghost, and we want to adjust that. And if you've been watching all the videos in this series, you've already seen how we can apply a collide behavior between one actor and another. And let's just do that again now. So I'll double click on actor 1. And I'm going to go down to where it says collide. I'm going to drag that up into this actor. And we want actor 1 to collide with what? the ground. So I'll click on this pull down and select the ground. And then let's preview this again. So actor 1 then collides with the ground, kind of just bounces off into outer space. So let's take a look at what's happening here. Well, there's a collision, but ask yourself, what does this feel like? Does this feel like we're on Earth? Does it feel like we're in outer space? Does it feel like we're on the moon? What does the ground feel like? Does the ground feel rough? Is it smooth like ice? In fact, we can come in here and quickly adjust things, which is again why I was stressing, why bother creating graphics when you can just do some really quick, rapid prototyping with simple shapes like this. So maybe we'll just adjust everything a little bit. And now if I hit preview, we can see a kind of a different simulation and see how things are working out. So again, take a moment to try to understand what's going on here. Our square feels very, very, very bouncy. And we want to be able to adjust all of these attributes. And again, that's by simply double-clicking on the actor. And you notice in each one of the actors we have this physics pull down. And let's take a look at a few of the things that we can adjust here. The first thing that we're going to look at is bounciness. So we have that set to 1, and this is a very sensitive attribute. So I'm just going to actually double-click on this and set it to 0. And if we preview this again, you're going to think maybe it won't bounce, but it actually looks like it's bouncing just as much as it did before. And that's because you have to pay attention not just to the bounciness and friction and attributes with the actor, but you also have to pay attention to those same attributes with the actors or objects it's colliding with. So we changed the bounciness for our white actor down to 0, but our ground is also very bouncy as well. So let's take the bounciness for our ground down to 0 and then preview this. So 0 for the white actor and 0 for the ground. And now you can see we get almost no bounce. Great. So now we can imagine that the ground is a very hard object and our actor, our white actor, is also a very hard object. But now let me ask you this question while we're looking at the simulation. Is this ground really, really rough, or is it really, really smooth? And I know you're going to pretty much say smooth. Why? Because our actor is sliding all over the place, right? So we can imagine this is almost like ice. So let's simulate the ground being a little bit more rough. So just as we saw for our actors, we have a bounciness attribute. We also have a friction attribute. And that's currently set to 3. So if we push this to something up like 10, and then preview, so again our ground's friction has been set to 10, you're going to see that we get a little bit less of a slide. And again, don't forget that these values also apply to the actor itself. So its friction is set to 3 and we can set that to 10. So now the ground and our actor have friction set to 10 and it slides even less. And we can keep pushing that value higher and higher and higher if we want to. So already just between bounciness and friction, you've been able to control a great deal of what's going on in your scene. We can make things look rubbery, we can make things seem smooth, or in this case, very, very rough. So now that we've taken a look at the bounciness and the friction behind physics, let's take a look at the collision shape that you apply to each object. So let's just start over quickly with a few new actors. So I'll create one actor, which will just essentially be my collision or ground areas. And just like before, we'll just kind of shape things up and quickly get a scene in position. And then I'll import some images. So I'll go over to my images, click the plus icon, and in my physics folder, I'll just bring in these two images, which is a blue sphere and a rocket ship. So let's start with the rocket ship. We'll bring that here into our stage. And we're going to set up gravity again. So with the Y axes, we'll set up 100. And if we go back to our first actor, which is acting as our ground, and go to physics, we can set this to not be movable, so we'll uncheck that. And if we preview this, you're going to see that our ship falls straight down, but our ground doesn't. So what we want to do is double click on the ship, and we're going to apply a collision behavior, or a collide behavior. And we're going to have this set to actor 1, which is our ground, and then if we preview, you can see our ship then bounces around. So again, let's kind of tighten things up a bit by taking our bounciness down to 0 for our ship, and we'll take the ground and we'll take the bounciness down to maybe a 0.2, not completely to 0, so there's a little bit of bounce left. Okay, so you can see that our ship is pretty much a rectangle. Now what I mean by that is, if we were to draw a bounding area around the ship, it would pretty much encompass a rectangle or a square because of its current shape. So that means that the way GameSalad is calculating the physics simulation is it's not really looking at what we see here, which is this shape of the ship, but it's essentially drawing a box around this shape. So a rectangle, and if we look at the ship physics attributes, you can see that the collision shape is set to a rectangle, and that's very appropriate for the shape of the ship. So if we watch it simulate, you can kind of see it's not exactly connecting with the ground in some areas, but it's simulating based on as if there's a rectangular box here. If we were to switch this to circle, it's now drawing a circle inside this bounding region, and we're going to see a very different simulation. You can see that part of the ship intersects and goes through, and you can see now it's starting to roll around like a ball, and that's because essentially there's this circle in the center of the shape. So depending on what you're working with, you may or may not want to have a rectangle, or you may want to switch it to circle. So for instance, if we just take our ship and delete it for right now, and we bring our ball into the scene, and let's also adjust its physics, so we're going to take its bounciness down to 0. And right now the ball, or the sphere, its collision shape is set to a rectangle. So essentially it's not really a sphere falling, it's a cube. Let's make sure we give it the collide behavior as well with actor 1. So you can see when it lands, it actually looks a little strange. So let's reset that again. Watch what happens when it lands. You can kind of see that square action happening. So in this case, we definitely want to switch it over to a circle as far as the collision shape. And you can see now this is reacting much more like a ball. So whether your actor is rectangular in shape like the rocket ship or circular like this ball, you may want to decide which collision shape you're actually going to work with. So don't forget that, so you can get an accurate simulation. Sometimes if something's rectangular, you still want to give it a circular collision shape, or vice versa. It's really just up to you and how you want the simulation to process. So take a moment to import different pieces of artwork and applying different collision shapes, whether it's a rectangle or a circle.